Well, I would say in and of itself, not too bad. I mean, we'll go through some skills. So simplify radicals. Some of them are easier than others, but we'll tackle it together, and everything will kind of feel not too bad. But it's the implication. It's the consequence of this particular lesson, and you think about how it fits in with everything else that we've been doing. So we've been learning about factoring and solving quadratics using factoring. Right? We've been getting clean answers, so integers. Sometimes you get it mix in a zero or a fraction in there. You know, nothing too crazy, but the fact that we're reviewing radical expressions tells us that now radicals are going to be fair game. So instead of having an answer of x equals 2 or x equals -3, it could be x equals 2 radical 2 or x equals 3 radical 2 over 2. Right? So it can get a little bit more complicated. And so we're going to learn some other techniques for solving quadratics that don't involve factoring and also don't really involve the calculator. Calculator is a good resource for checking, but it's not a good resource for doing the work for you. All right, so very important stuff. This is one of those topics where when you first learned about it, you might have been a little iffy. You might have been thinking, you know, it'd be really nice if I get another look at how to do this stuff, because I never really got it. Well, this is your opportunity. So if you were a little iffy on simplifying radicals, then this is your opportunity to get back in the game. All right? So, well, a radical expression, I mean, sometimes I feel like I overdefine things. A radical expression is an expression that contains a radical. Yeah, of course. I mean, what else would it be? So here's an example of a radical expression. It's something with a radical. Right? The square root is the cleanest type of radical. It's the one that gives a non-radical answer. Right? That's really what all this stuff means. Right? So if you were to simplify a radical and get an integer, or a whole number that doesn't involve a radical, then what you're looking at was a perfect square, right? So what you found is a square root, right? So we'll list out some perfect squares, just so they're fresh. Use my blue stylus. All right, the smallest perfect square would be 1. Then the next one would be what? 2 squared, which is 4. Then 9, 16, 25, 36,
49,
64,
81, 112,
121,
144, 169.
8.
Let's go up to 15 squared. What's 14 squared?
225.
Well, that's 15 squared.
Oh, wait.
So I'll take that. But what's 14 squared? 196.
190.
All right. I mean, obviously you can keep going, because any number that exists could have a power of 2 associated with it. So I could go on, but after you get to 15, then you start kind of cherry picking and choosing the ones that are most popular. So after 15, you don't commonly see 16, 17, 18, 19. Sometimes 16 comes up, 256. But the next popular one after that would be 20 squared, which is what? 400. That's a pretty easy one. Then 25 squared, which is 625. Then 30 squared, which is 900. And then you basically end up being multiples of 10 squared, in which case you could figure it out pretty easily in your head. All right, but these are the ones where you probably want to, if you don't have them committed to memory, at least make the attempt to commit them to memory, because it makes life a lot easier. The smaller ones you should already know. Sometimes it takes a second to kind of refresh your memory, but these should be more familiar. When you start getting past 12, because for some reason multiplication tables ended at 12 by 12, I don't know why. Well, actually, I do know why. so that they can try to purposely trip you up by asking you to multiply things that don't involve numbers from 1 to 12. So it'd be like, all right, study these multiplication tables from 1 to 12. Know it like the back of your hand. All right, cool. You ready for the test? All right, what's 13 times 14? You're like, look, why'd you have me study the 12 by 12? You're telling me 13 by 14. That doesn't seem fair. So, but that's generally how it works. So whatever you don't know from this list, try to commit to memory. But really, if you think about it, it's just the numbers 1 through 15 squared, right? So if you needed to, you could always just crank out those values on your calculator, right? So just raise each of those numbers to the power of 2. There's shortcuts, but that's a different story for a different day, I think. 50, the square root of 50. When you're trying to simplify a radical, what you want to do is write it as a product of a perfect square and something that's not a perfect square, unless the number is itself a perfect square. So that 50 is not in my list. All right, it could never be in my list because this is the list of perfect squares from 1 squared to 15 squared. 50 is not in this list, and I've accounted for everything. So it's not a perfect square. But I do need a factor of 50. This is where Ken puzzles, if you've actually taken those seriously and actually tried to learn how to do them, that knowledge comes in handy because the whole thing related to Ken puzzles is knowing about factors of numbers. Okay? So like we've been learning about factors of algebraic expressions. Factors of numbers is, I think, harder because you would think it would be easier, so people don't give it the time it deserves. Right? So I need 2 factors of 50, one of which should be a perfect square, but I want the largest perfect square that divides evenly into 50. 25. So 25 and 2. All right, so 25 times 2. Now it's possible that you could choose a number that is a perfect square, but it's not the largest perfect square. So you may have multiple steps coming into play here. All right, but if that's the case, and you got the largest perfect square, then you can go right to the process of actually taking the square root. The square root of 25 is what? 5. The square root of 2 is not, well, it's not a perfect square. The 2 is not a perfect square. And also it's not a product of perfect squares. Well, technically it is. Like everything is a product of 1 and itself. But if I broke this up into the square root of 2 times the square root of 1, it doesn't get me anywhere. Right? So that's the trivial case. We ignore that. So we just hang with the rad 2, bring that down. And 5 rad 2 ends up being our final answer. All right. So then we get to 108. 108 is a little trickier. We want to think of 2 perfect square numbers. Well, 2 perfect square. A perfect square number that divides evenly into 108, understanding that there could be multiple perfect squares that divide evenly. 36 is the best one.
Oh.
36 times 3. All right. So that's the issue that you run into, because there's a few things that divide evenly into 108. You might have thought 4, right? Because 4 times 27. Right? You might have thought 9, because 9 times 12. Right? So, but you might not have thought 36 times 3. 36 is the largest perfect square that divides evenly. So the 36, the square root of 36 is 6, and then bring down the root of 3. Right? So, I mean, the issue that comes out of this is, well, it's frustrating more than anything, because if you chose the wrong value, you'd have more work to do. So let me just do it off on the side real quick. So let's say I accidentally thought that 4 was the best multiplier. All right, so I thought it was the square root of 4 and the square root of 27. right? It accomplishes something, but it doesn't get me all the way. Square root of 4 is 2. And then I have the square root of 27. So I just carry that down. What I have to do is reevaluate. I have to look at my square root of 27 and ask, is that a product of a perfect square and another number? All right, 9 and 3, right? So the square root of 9 and the square root of 3. The square root of 9 is 3. And you're stuck with the rad 3, so leave that alone. So basically in your final step, let me just get purple. I have these unique factors, 2 times 3 times rad 3, which would eventually give you the 6 rad 3. Perfectly fine. You got the correct final answer. But look at all this extra work you had to do just because you didn't take the extra time to consider what the largest perfect square number that divides evenly into 108. All right. The good news is you still have the technique that you could use related to the x chart. So if you put in 108 over x in your calculator and then go into the table, it's still going to give you the list of factors, right? Just like we used it for the x chart. Then you have to look at those factors and actually think. Yeah, I know. It's frustrating. I don't like doing it. I like just hitting enter. Yeah, that's my answer. Call it a day. But no, you do have to think. Be like, is this my best option? Go down the list until you run out of options, and then consider what the best out of all of those possibilities would be. All right. Some of them are not bad. Like root 20. Product of what and what? 4 and 5. So 2 rad 5. Bless you. Sometimes it's part of an operation. So root 200 over 2. I would ignore the 2 because one of the operations associated with radicals is if I'm going to divide radicals or multiply, I can only divide a radical by a radical. I can only multiply a radical by a radical. I can't divide a radical by a non-radical value. Right? So if you were to come up with a radical 100 out of this, then that's completely wrong. Right? What we do is we ignore the 2, at least in the first step, and just focus on the rad 200. This should be a pretty easy one, because there's a nice perfect square value that divides evenly into 200, 100, and 2. So we're looking at 10 rad 2. The only thing you got to be careful about is, well, that's not my final answer, because that's just the top. So I have to build my fraction with this as my numerator. All right, so I'm going to write this as 10 rad 2 over 2. Now, just as I said before, you can't divide a radical by an ordinary number. You can divide 2 ordinary numbers. I got a 10 and a 2. Neither of those values are radical. Those can be divided. So I would end up with 5 radical, oh, that's not a radical, 5 radical 2. All right. For the next one, we're looking at the square root of 300, which is going to have the same structure as the square root of 200. So you can rely on prior knowledge. I do that all the time. Makes you look smarter. Like, yeah, I taught this class like 17 times before, so I know the answer to this question already, but like I pretend I'm figuring it out in my head at that moment, and you're all impressed. Like, wow, he just did that in his head. No, I just remembered it from the last 3 times I did it. Yeah, so same idea here. I just remember that this and this would have the same structure. So if this were 10 radical 2 related to rad 200, then the other one would be 10 radical 3. And I ham it up a little bit to make it seem like I'm being devious, but not really. I'm making use of my resources. Like I already did the work here. Why would I do it again? It's the same problem, at least on the top. So I'm not going to kill myself doing this work again, because it's just going to become rad 100, rad 3, and the rad 100 is going to become a 10. So why not just cut to the chase? Then I put it over to the 3. And at that point, I can see that, well, 10 and 3 are not going to divide unevenly, so I'm just going to leave it as is. Okay? So that's the simplest form. Then we have the last one, which, you could try to do something along the lines of 4 and 5, but it's not similar enough to 4 and 5 for you to get away with that. So what I would do here is kind of revert back to what I did in 4. Break up the 54, which would be the product of what and what? 9 and 6. So 3 rad 6. That's the top. So we're looking at 3 rad 6 over 6. Simplify. The 3 will go into the 6 twice. So 3 goes into 6 2 times. Final answer. Radical 6 over 2. There are calculator tricks to this, but I sometimes worry that at least for this topic, that it might be more trouble than it's worth. So I sort of avoid that kind of thing, or at least for this one particular topic. Generally, like I said before, you can use your calculator to check your work, because all you have to do is type in what you started with, type in what you came up with, and see if they give you the same decimal. The problem, the major, extremely major drawback to that approach is example 2. We chose 36 and 3, came up with 6 radical 3. That was great, but you might have stopped right here, never considering that radical 27 could be broken down. So if I went to my calculator and typed in rad 108, hit enter, got a decimal, and then typed in 2 rad 27, hit enter, got a decimal, it would give me the same decimal because they're equivalent. But the problem with that is, yeah, they're equivalent, but this is not as simple as it can get. All right? Instead of dealing with the decimals, I don't like the decimals. They're telling me on my fancy new laptop that I'm eventually going to have a graphing calculator just like this one installed, so I'll be able to display it up here, which is going to be annoying because I'll have to go back and forth from screen to screen, but they're going to be taking this out soon. You'll miss it. All right, so the square root of 108 and 6 radical 3 should be equal to each other. So second math equal sign 6 radical 3. True. All right, it's a true-false relationship. So you type in the relationship you think is true, and the calculator will confirm or refute it. So if I got a 0 back for this, the calculator would be saying that that's a false sentence. All right, so second math, option 1 for the equal sign. And you have your other inequalities in there also, so that's kind of nice, but at least at this point, this is all we care about. So benefit of this approach, I'm just thinking regions, multiple choice questions. Aside from the trick question, because there will be one, obviously, because there always is. Like I'm going to put, so radical 108, what is the simplest form for radical 108? One of the choices is going to be 2 radical 27. So you just got to be careful not to select that one. But you can at least eliminate the unreasonable ones just using that technique. All right, just use the equal sign on your calculator. If it gives you false, at least you can kind of thin down the mix a little bit.